So here I have a lens that I've optimized. It's a singlet lens, it's all spherical surfaces. The variables are the radius of the front surface, the back thickness of the lens, and the radius of the second surface is actually controlled by an F number solve, making it F5. If I want to improve this lens any further, one thing that I can do is make it aspheric. And Zemax has a handy tool for investigating this. It's called the Find Best Asphere tool. And if I use that, and I'll just set it to look at from surface 2 to surface 3, and I'll start off with a low order asphere. And I'll press start, and you can see here the current value of the merit function, and then you can see that the merit function greatly reduces by putting an asphere on surface number 3. If I want to see if I can get any better than that, 6th order asphere, start, and it does in fact make further improvements. It gives me a merit function that's very, very small, this time on surface number 2, and I think I'll just go for the 4th order asphere. That's about as good as I want, so that's fine. So let's just say I'll keep and exit that. You'll see the design is nicely diffraction limited. Look at the optical path error. You see it looks like so. And here's my aspheric design. It has just a 4th order term, 4th order coefficient on it, and because I'm not using these other terms, I'm just going to hide them. I'll hide this one as well. So that's my aspheric surface. One thing that I may want to look at as well is the actual curvature of that surface, which I can get to under the surface tabs here. I'll look at the curvature cross section, and I'm going to choose surface number 3, which is the aspheric surface. And this is showing me the departure from sphericity of this lens. Curvature is 1 over the radius of curvature. So right at the center of the lens, the curvature is given by 1 over the radius of curvature of the lens in the editor. But then the asphericity term starts to have an effect, and I'm getting this kind of response. If I want, I can rescale the lens like so, or rescale the graph rather, just to make it easier to draw, and I can also use my scroll wheel to zoom in and out on the curvature points. So that's looking at the asphericity of this data of this surface, and this is particularly important if I have a multiple order asphere where this curve goes through turning points, because it's turning points that are difficult for manufacturers to make. So this is a reasonably straightforward asphere for a manufacturer to make.